Hello, I'm JW, and this time we're going to be having a look at certificates. Now this will be in several parts, so first time we're just going to look at the general overview of them, and then we'll have a look at the individual certificates at a later date. Now certificates are not a new idea, and they've got nothing to do with Part P, so don't think anything about that, and they don't really have anything to do with belonging to a particular organisation, such as the ECA or the NIC, EIC, or any of the other dozens which now exist. Now, certificates go back a very long time, and if we have a look here in this particular edition of the wiring regulations, you can see here on page 74 that there's an example given here of a thing that should be filled in once you actually completed an installation. Now, this particular one is from the 13th edition, which was issued in 1955, so that's well over 60 years ago. So certificates were around then and have been pretty much for the whole time. Now, of course, certificates have changed quite a bit over the years, but the actual idea of them hasn't. It's basically been in the regulations very much forever. Now, the current version of the regulations is this one, which is the 17th edition in the yellow cover, and that's at the time this video is made, which is in January 2018. But, of course, when the new one comes out, it's obviously going to be a similar deal. And the regulations do have examples of the certificates in the back. I'll just have a quick look at those three. But normally you're not actually going to be filling those particular ones in because, of course, they're stuck in the book and there's only one. Now, in theory, you could photocopy those or something and use those. But in the real world, it's more likely going to be buying a pre-printed set of certificates on a pad because it has the advantage then when you write on them, it creates another copy underneath. So you give one to the customer or whoever, and then you can keep the other one. And of course you can get various computer software which you can then just fill in on the computer or on a phone or tablet or whatever, and then either email it to the customer or print it out later. So several options there, but the basic principle of course is the same. How you fill it in, whether it's a pen or a tablet or whatever else, doesn't really matter. Now the first certificate, probably the most commonly used, is the Minor Electrical Installation Work Certificate, or just Minor Work Certificate. And we can see the example here in the regulations. And as it says at the top there, it's to be used only for minor electrical work, which does not include the provision of a new circuit. So this is pretty much anything that is not a whole new circuit. So it could be extending an existing circuit, say adding lights or adding sockets or whatever else. It could also be replacing items, so new lights being put in or replacing things which were damaged or broken. So a whole load of stuff covered by that, and it really is the one that's used by far most commonly. And it's a very short one, it's generally only a single page, and it has a very short amount of information contained on there. Now the second one is the Electrical Installation Certificate, and this covers everything else, which is essentially going to be new circuits and any kind of new installation. So whether it's just a single circuit being added to an existing system, or in fact just buying a whole new installation with new consumer unit and whole loads of new circuits as well. And this covers several more pages, and as you would expect, there's quite a lot more information that needs to be put down there, and it can be used, say, for a whole installation with many tens or even hundreds of circuits if necessary. So again, it's in the back of the regulations there, and there's an example layout given, and so that's only going to be used for new things. Now the third one is not used once you actually installed or changed anything, it's purely after an inspection and test has been done. Now this is currently called the EICR, or Electrical Installation Condition Report. It was previously called a PIR, which was the Periodic Inspection Report. But the concept of it is the same. It's essentially where you're going to be inspecting and testing any kind of existing installation, and then just making a report on what the condition of that is. So you're not actually changing anything or installing anything, it's purely just looking at it and testing it as appropriate. And as you would expect, this is quite a lengthy document. It goes over many pages in most cases, and will obviously include things like the things you found which don't comply with the regulations, things which may need to be repaired or obviously are in a dangerous state, and of course any test results for the various circuits and things which are involved. Now this is the easiest certificate, as it's the shortest one, and it's also by far the most common, as it says here, it's to be used for minor electrical work which does not include the provision of a new circuit. So it's pretty much everything else apart from a whole brand new circuit, and of course not brand new consumer units things as well, because of course those would also include new circuits. So basically it's replacements, minor extensions, additions and all that kind of thing. Now it's only a single page here, and this is the top of the page, and it basically just goes down and ends there. And so this is the model certificate from the regulations, and if you buy them they may well have a slightly different layout, but essentially it's going to be the same information contained within. So first of all then is the description of the minor works, and that's basically just a description of the work which was completed. So in this case I'm going to use a red pen because it's easier to see in contrast to the background, but in this case we're going to say it was adding a socket outlet in the bedroom, and that could be for a television or whatever else. So just basically a brief description of what was actually done. So part number 2 is the location or address. So again, that's the address of wherever the work was done. So we'll just fill in the address there. So there we go. So nothing too mysterious there. Date it was completed, and again that's obviously just the date there. So we'll say that was the 10th of January 2018. So again, pretty obvious stuff. Now the next part here, details of departures, if any, from BS 7671 2008. That's the current version we're using at the moment, the 17th edition. Now in 99% of cases there shouldn't be anything in here, because basically if you're putting something in here you're basically saying that the work you just did does not comply with the regulations, so you better have a pretty good reason for actually putting something in there. So in most cases that's going to be not applicable or none, because of course the whole point of this is that you do the work and it does comply with the regulations. But if for some inexplicable reason there was something which did not comply with the regulations, then you could actually write that in there. But say it's very unlikely, because kind of the point of the regulations is to comply with them, and if you're not going to bother complying with it, well, why would you be bothering to fill this thing in the first place? Now the next bit, number 5, is details of permitted exceptions, regulations 4133. It's a bit difficult to see, but it says where applicable a suitable risk assessment or assessments must be attached to the certificate, and then you would tick the box here if you had done one of those. So let's just see what 4133 actually says. So here is 41133, and it's about additional protection, and primarily it's about RCDs being installed for things like socket outlets and other equipment. So an exception here is permitted, and this is what we're talking about on the details of permitted exceptions. So essentially, in AC systems, additional protection by means of an RCD is required for socket outlets with a current not exceeding 20 amps and for mobile equipment for use outdoors. So in most cases it's going to have an RCD, but an exception to that is permitted where, other than for the installation in a dwelling, a documented risk assessment determines that the RCD protection is not necessary. And bear in mind that's for not in a dwelling, so that might be in a commercial or industrial environment. Or B, for a specific labelled or otherwise suitably identified socket outlet provided for connection of a particular item of equipment. That would be something like if you had in a kitchen, for example, a particular outlet which was only used for a fridge and was labelled accordingly, then you could have the circumstance where you did not require an RCD for that. So those are the exceptions that it's pretty much talking about. So in those cases you would actually write this in here. So you put something in like socket in kitchen for fridge only, does not have an RCD, or if it was in an industrial or other environment, you could then have a risk assessment done and attach that to this document and refer to it here. However, in most circumstances this is not going to be applicable, and in the case of this we're going to put not applicable as well. Bearing in mind that the regulations are the forthcoming, which though they haven't been published yet, it's going to pretty much require RCDs on everything, so this section is likely to be even less relevant in the future. So that's pretty much the start there, and essentially just a description of what you've done, where it was, and whether it complies with the regulations or not. Now then we have part 2. Now this basically describes the installation. So first we have the system earthing arrangement, and this will be one of the 3 types here. Although there are other types, they're not generally used in the UK, and in fact some of them aren't even permitted. So you're just simply going to tick the one which is appropriate here, and I've done a video on these separately, so you can go and look at that if unsure. But as a quick reminder, TT is the one where you're providing your own earth with an electrode in the ground, so you get nothing from the supplier. TNS is where they're providing the earth as a separate, as in the S part. It's typically in older buildings. And TNCS, also quite often referred to as PME, typically what you're going to find in a newer installation, and that's where the cable coming in the building has just 2 conductors. The neutral and protective conductor are shared, as in combined, and then they're separated once they're within the installation. So it's just a question of ticking the appropriate one. In this case, we'll say it's the TNS version there, so possibly an older installation. Now, method of fault protection. Now again, there are several methods of fault protection, but in reality there's only one which is going to be used, and this is ADS, and that actually means automatic disconnection of supply. So in other words, when a fault occurs, the supply is disconnected automatically, and generally that's going to be a fuse blowing or circuit breaker tripping or RCD cutting off. So although there are other methods, in highly unlikely circumstances you might use them, but 99.9% of the time it's going to be ADS, because the other methods are very seldom used, and again we may look at those in a separate video. Now, protective device for the modified circuit. So protective device means, say, the fuse or circuit breaker or whatever else. I think it pretty much ties in with the previous item. That's the method you're using, and then you're just going to give the information of what that thing actually is. So you've got protective device for the modified circuit, type, and also a rating. Now, obviously this depends on what you've actually got. So in this case, we'll say it was a ring circuit. We just added an extra socket to that. So in the case of the rating, that's going to be a 32 amp, and type in this case is going to be a circuit breaker, and we could also put it was a type B if we wanted to, and equally that could be a fuse, say a rewirable fuse or cartridge fuse. Various different ratings of course do exist as well. So again, you're just describing what the existing equipment already is. Now, comments on existing installation, including adequacy of earthing and bonding arrangements, and again refers to 132.16. Here's 132.16, and refers to additions and alterations, so no surprise there. And so no additional alteration, temporary or permanent, should be made to an existing installation unless it's been ascertained that the rating and condition of any existing equipment, including that of the distributor, will be adequate for the altered circumstances. Furthermore, the earthing and bonding arrangements, if necessary for the protective measure applied for the safety of the additional alteration, shall be adequate. So essentially what the part of this here is for is to just confirm that what you've added to is actually already safe and fit for purpose. So in this case, 32 amp circuit with the ring there, that's no problem. But if you got somewhere and found that someone had an old fuse system and they just shoved a piece of nail or something in the fuse instead, pretty obviously that's not going to be suitable. And likewise, if you found that the circuit breaker was, say, a 63 amp job on a lighting circuit, well, again, pretty obviously that's not acceptable either. So this is really just a description of things, just to confirm that you did actually look there. And particularly in the case of the earthing and bonding, so you could put in here, for example, the main earth is, say, a 6 square millimetre in copper, and bonding to gas and water was confirmed also as being, say, 6 millimetres as well. Now on new ones that would generally be 10, but bearing in mind on older installations that TNS can be somewhat smaller, that's perfectly acceptable for an older installation. It's not necessary to go in and alter these things, but you do need to actually confirm that they do exist, because if they didn't exist that's going to make a bit of a mockery of the automatic disconnection, because no earth is not going to actually work. So just a couple of comments there if necessary about the existing installation, and if there was anything else which, say, was slightly unusual, whatever, you could write that in there. But again, bearing in mind that's not necessarily directly related to what you've done, it's just confirming that basic items for safety do actually exist. Then we have part 3, which is the essential tests, and so in other words, not all of the tests necessarily, but certainly the basic ones to confirm that the thing is actually suitable and safe. So earth continuity. Again, it's pretty important to make sure this is there, so in the case of the socket we need to confirm that the earth in the socket is actually connected to the installation earth. So again, we can just tick that once we've done the test for that. Installation resistance. Again, that's a fairly important test, because if you don't do that then there's a good chance of things being shorted or damaged within the cabling you just installed. Again, you just do the test with the installation resistance meter. I've covered tests in another video, and then we just write in the results here. Now in this case it's a single phase circuit, we're just adding it to somebody's house. There is no live to live option, because that would only apply to a 3-phase installation, so not applicable. And live to earth, that could either be, say, the line and neutral to earth combined, or you could do them separately, and we would write in the value of that in here. In this case we'll say it was 200 megohms. earth fault loop impedance, which again you would measure at the socket which we'd installed in this case. We could put the value in there from the test results there, 0.77 ohms. Polarity is satisfactory, and again this is not about positive negative, this is basically confirming that line is in the correct place and neutral is also in the correct place, so again you would check that at the socket installed in this case, confirm it is okay. And then the RCD operation if applicable. Now in the case of this one it is going to be applicable because bearing in mind it's a socket. Most circuits and new installations will have an RCD, but there may be some older ones which don't and don't actually require them. And again you would test that with the testing device, and then simply just fill in the results here. Now the operating current is going to be on the device itself as in the RCD, so that will normally be a 30 milliamp device. Others are available for different purposes, but for sockets and things 30 would be the expected item. And then the times, you will need to test the RCD to confirm that it does trip within the required times. In this case we'll say that our test results we had were 27 milliseconds and 8 milliseconds. And satisfactory test button operation, in other words when you press the test button on the front of the RCD, does it in fact trip? And of course we would confirm that it does. If you found it didn't, then of course it would need to be replaced and you wouldn't be filling this in at all. Likewise, if you found that the socket had been connected up incorrectly, you would need to go and fix that before filling this in. And if you found the earth loop impedance was, say, 300 ohms, then clearly there's some major problem and you would have to find that as well. So this is only filled in once you've actually completed the installation and actually confirmed everything is working properly and is safe. Now part 4 here is just one little bit to fill in. So it's I certify that the said works do not impair the safety of the existing installation, that the said works have been designed, constructed, inspected and tested in accordance with the wiring regulations of the current edition. And amended to, and then in here you will just need to put the date in of the particular edition you're using, because bearing in mind the 77/1/2008 is when the 17th edition was initially published. We're now on the third amendment, which was printed in 2015, so we'll put 2015 in there, and of course you would amend that depending on which one you're using. And the said works, to the best of my knowledge and belief at the time of my inspection, complied with BS 7671 except as detailed in part 1 above, but as we saw earlier 99% of the time they will. So you're basically saying that what you've added has been tested and is safe and suitable for use, and what you've added isn't actually going to impair the safety of what's already there, as in you're not going to start overloading the circuit by adding too many other things or causing things to be damaged. And then finally at the bottom it's just a question of your name and address, so obviously we'll just fill that in as appropriate. And over here then you would just simply sign as appropriate your position within the company, so maybe electrician or owner or whatever. And again the date, pretty obviously, is just the date in question. So that is pretty much it. And although that took a while to go through that, in reality it's a fairly quick thing to fill in, because part 1, what you did, where you did it and when you did it. Possibly one of those two if it doesn't comply with certain things, but in reality it should be complying, so those two would seldom if ever be used. Type of installation you've got, so the type of earthing, type of fault protection and the circuit breaker, fuse or whatever else. Maybe you put a comment in there about the earthing and bonding. Part 3, the tests you've done on the installation you've actually put in, and again it's things like your earth continuity, installation resistance, earth fault loop, polarity and the RCD operation, assuming it has one, and most will. Filling in the date of the particular regulations that you're installing it to, and then it's just your name and details at the bottom. So that's certificates, or at least the first one, and we'll look at the other ones in later episodes. Now in terms of who should fill in the certificate, well most of the time it's going to be the person who actually just did the work, so in this case you would install the socket in the bedroom, do the test to make sure it's safe and of course not going to kill people, and then fill in those results on the certificate as we saw. So not really any particular mystery about it, it's just recording down the information which you already have. And it may take a bit of time to write down, but say in the case of that one you're looking at a couple of minutes in reality, because say you're not going to obviously go through it in the detail we did there. So certificates are not particularly related to Part P, because say Part P is part of the building regulations and certificates existed for decades before that was invented. And again, it's not necessarily connected to belonging to a particular organisation such as the NIC, EIC either. Now, if you do belong to these organisations, they can provide you with a certificate pad, things with their logo on and, say, a registration number or whatever else. I think obviously you would probably use those in those circumstances. But it's not compulsory to belong to these organisations, and if you don't, then you can just simply buy certificate pads from a variety of sources, which obviously are sort of generic ones, and fill those in instead. So no particular mystery there. It's just recording the information and basically writing it down as required. So that's it for this time. Say later on we'll look at the other certificates, but until then, thanks for watching.